So today we are going to be talking about this problem about inverse demand functions and own price elasticity. So this is the question. Suppose your friend collected data at her local Gasco station. Prices in dollar per gallon, quantity in thousands per gallon. So we have the data right here. Your friend estimated an inverse demand function P of Q on these data. P equals 2.6 minus 0.025 times Q. What is the expression for the own price elasticity of demand according to this equation? Is this demand isoelastic? So to compute the own price elasticity of this quantity, we have to recall the definition of elasticity. So the definition of elasticity is, elasticity, it's defined as the percent increase in demand divided by a percentage increase in price. So what does this mean? Well, how do we calculate the percentage increase in demand? Well, it's the delta Q, the change in demand, divided by the demand, that's the percentage change in demand, times 100. And then we divide this by the percentage increase in price. So this is delta P over P times 100. Okay, so then this formula actually simplifies quite nicely. The 100s cancel out, and we simply have delta Q divided by delta P, and then times P over Q. And this formula is often reported in terms of differentials, not incremental changes, but differential changes. So this is equal to dq dp, or sometimes this is actually, sometimes we can actually write this as partial q partial p, because the quantity can depend on other things like the weather or this time of year or the presence of a pandemic, times P over Q. So this is the formula we can use. So for number one, we will, let me use a different color. So number one, what is the expression for the own price elasticity? So we have P equals 2.6 minus 0.0025 Q. And so this is, we can write this as, actually, let me go back, Q. And this means that partial P partial Q is equal to negative 0.025, right? And this implies that we have, this is, oh sorry, I missed a 0. This is actually, this thing can also be written as 1 over 400, or negative 1 over 400. So this implies that partial Q partial P is equal to negative 400. Okay, so then we have to, but this is, we're not done here. We have to use this expression for the own price elasticity. So usually we think of price as the dependent variable, and quantity as the thing that is affected by the price. So we're going to write everything in terms of price. So epsilon elasticity is equal to negative 400, because that's the derivative of Q with respect to P, times the price, whatever the price is, divided by the quantity. Now, to get the quantity, we have to invert this function. So basically, we can write this as this is also is equal to 2.6 minus q over 400. So solving for q, let's solve for q. We have we can multiply everything by negative 400. So we get negative 400p equals, we multiply 400 by 2.6, and we get 1040. So 1040, negative 1040. And then we get plus q. So we get q equals 1040 minus 400p. Okay, so then we can plug this in. So this is 1040 minus 400p. So this is the expression for the own price elasticity of gasoline using the inverse demand curve that our friend here estimated using this demand curve. Okay, so let's move on to question 2. Let's calculate the own price elasticity of demand in week 1. Okay, so what is the own price elasticity of demand, or what is the own price elasticity of demand in week 1? So let's use a different color for this. So for question 2. Okay, so now we just plug in the price at week 1. So the price is 2.5, and if the question is a little bit imprecise, but I have interpreted this as meaning we use the estimated inverse demand function to calculate the own price elasticity at week 1. So the price is 2.5, so we have epsilon is equal to negative 400 times 2.5 over 1040 minus 400, 1040 minus 400, 2.5. Okay, what is this equal to? This is negative 400 times 2.5 over 1040. This is equal to 1,000, so this is equal to 40. And the 4's cancel. And so this is equal to, or the 40's cancel, I should say. 40. This is 40 times 10, so this is negative 10 times 2.5. And this is equal to negative 25. Okay, so that means that the own price elasticity of gasoline is negative 25. That is a huge number. That means that if we have a 1% increase, if we have a 1% increase in the price, that's a negative 25% decrease in the demand. That is huge. That seems a little bit unreasonable. It is curious. Usually in economics, we don't see elasticities this high. This is extremely elastic demand. So what is up with this? So we point out to our friend a number of facts. First, wholesale prices of gas experience weekly changes. At this time of the year, the demand for gas is relatively stable. And between 3 and 4, one of Gasco's oil tankers ran aground and spilled oil into the ocean, which spurred a partial boycott of Gasco for the remaining weeks of the sample. So if the demand is relatively stable, it means that this elasticity is a little bit unreasonable. So, and also it suggests that there should be some discontinuity between weeks 3 and 4. So let's plot the 6 equilibrium points as well as the demand function that we measured, that our friend estimated here. So let's do that. So I went ahead and did this ahead of time. So Let's see. So I plotted the points here along with the estimated inverse demand function. Let me use a different color. So these are the 6 points, and you can see that this is week 1, this is week 2, this is week 3, this is week 4, this is week 5, and this is week 6. So you can see that there is kind of a discontinuity in terms of the demand function. These look like relatively straight lines, and it looks like this single estimate did not capture the fact that there are 2 separate demand curves here. And in fact, this estimated curve has a slope that's much too low. So in other words, the dq dp is much higher. dp dq is much lower, but the dq dp is much higher than it should be, which implies that elasticity has been overestimated. Okay, so let's actually draw lines through these points, and I've done this down here. So let's draw lines between these points. Okay, so now we have 2 actually separate demand functions before the boycott. So this is before boycott, and this is after. Okay, so how do we now estimate these inverse demand functions? The question says we don't actually need to know about regression, and so the way we do this is the line goes through all these points. That's a convenient part about this problem, and so we can just literally take the line that goes through 2 of the points and use that to estimate the inverse demand function. Okay, so this point here, this point is, so we're going to use, for the before, we're going to use these 2 points. So this point is let me go back. This point is 104, 2.4, and this point is 100, 2.5. So we can use point slope form of a line, which says that P minus the price of 1 point equals 2.5 is equal to the slope, and the slope is given by, let's say, 2.4 minus 2.5 delta y over delta x, 104 minus 100, and then this is Q minus the demand at that point, so that's 100. Okay, and we can simplify this. So this is P minus 2.5 equals, this is 0.1, or negative 0.1, so negative 0.1 over 4, Q minus 100. Okay, so this is negative 0.025 Q, and then this term ends up being, this is 25, and then the negatives cancel, so this ends up being plus 2.5. So then we can set P, we add 2.5 to both sides. This is equal to 5 minus 0.025 before. So this is one of the demand curves, inverse demand curves. Okay, the second one is very similar, except, let me use a different color. Except we'll use different points. So this here, we'll use this point, which is 100, 2.2. and then we'll use this point, which is 96, 2.3. Okay, so then similarly, we have p minus 2.2 equals, and then we have 2.2 minus 2.3 over 100 minus 96. And then q minus 100 again. And this slope ends up turning out to be the exact same. So this is negative. So this right-hand side, the numbers are slightly offset, but it ends up being the exact same thing. So negative 0.025 q plus 2.5. And then this, and so then we add 2.2 to both sides, and then we get p equals negative 0.025 plus 4.7. And this is after. Okay, so now we need to ask the question, what is the own price elasticity in week 1? So this is actually pretty easy. In week 1, dp dq is given by this blue expression, and it is just negative 0.025, which is actually negative 1 over 40. Okay, so that means dp dq, or sorry, dq dp is equal to negative 40. So that means the expression for the own price elasticity is negative 40 times the price. And the price at week 1 is this value here. So it's going to be 2.5 over 100. This actually happens, this is 2.5 over 100 is equal to 1 over 40. So this is equal to negative 40 over 40 equals negative 1. And so that means that the own price elasticity is negative 1, which means that a 10% increase in price causes a 10% decrease in demand, which is very reasonable. Okay, thank you for watching.